Hello and welcome to Workshop 4 today on March 1st, 2014. My name is JD Crumity and I will be running today's workshop session for the Elementary School VEX Robotics. Okay, let's get started. So here again we have the System Challenge Academic Year Pacing Guide, which show where you should be right about now with working on your robotic solution. So we should be right now at Cycle 5, where you will construct a prototype design. So students will construct their prototype based on their robotics project design solution. So the first topic that will be covered in today's workshop is what timers are and how you can use them in your robotic solution. Now, timers can be thought of as time sensors or stopwatches, and timers keep track of time while other code is running. Your VEX robot is equipped with 4 timers that are labeled T1 through T4. And to use a timer, you first have to reset it using the clear timer command, and once the timer is reset, it immediately starts counting time. To find out how much time has passed since the timer was reset, you use the time1 command with, in brackets, you put the timer name, either T1, T2, T3, or T4. And this command is very similar to the VexRT command that we used in our last session. And just like how that command accessed the values of the specified channel, time1 gives you the amount of time in milliseconds that has passed since you reset the timer at the moment when you run the code. Now recall that each round of the robotics competition of the System Challenge lasts 2 minutes and 30 seconds. So if the robot continues to move after the time limit has passed, then none of its actions after that point will count towards the team's score. And a timer can be used to make sure that your robot stops receiving commands after the competition round has ended. Now, the code here is an example of how a timer can be used to make the robot stop accepting commands when the competition round has ended. So you have the task main command followed by clear timer, and a while loop for when time 10 for T1 is less than 15,000 counts, and you set the motor power, and then you have motor, left motor, and right motor equal to the VexRT channels divided by 2, and outside of the time loop, the while loop, you have the motors set to 0. So here we'll dissect the code line by line. So at the clear timer command, as we know, it resets timer T1. Now the condition of the while loop here says that it will repeat the command within the body until 15,000 increments or ticks of 10 milliseconds have passed since T1's reset. Now, I would like to point out here that in this while loop, you use the time 10 command instead of time 1. The reason being is that Robot C, each of the time commands can only count ticks up to about 17,000 or so. So while time 1 only gives the ticks in increments of milliseconds, time 10 gives it in 10 milliseconds, and there's another command, time 100, which gives you in 100 milliseconds or 1/10 of a second. So since our, and down here you can see the math that I use to figure out how many ticks we need, because each tick for this command is 10 milliseconds, and then that's just 1/1000th of a second, and you divide that by 60 to get it in minutes, which gives you 2.5 minutes or 2 minutes and 30 seconds. So since the, if I were to use the time 1 command, it would stop counting before it reached 2.5 minutes. So that's why we have to move up to time 10. Now the next line of code that we have here is setting the left motor and the right motor equal to the corresponding VexRT vertical joystick channels divided by 2. So this means that as long as the while loop condition is true, you map the vertical positions of the remote control joysticks to the robot's motor power levels using a 1-to-2 mapping. And then outside the while loop here, you have these commands that set the motor's power levels equal to 0. So in other words, once the timer has been called, your robot will turn off its motors and it'll stop moving, and then the code will end. Now, although using timers can be helpful in ensuring that your robot does not accept commands beyond a certain amount of time, there's still one flaw in the programming that we've covered so far. So think about this. How does the robot know when to reset its timer and begin counting seconds? So if we were to run the code that we have right now, it'll cause the robot's timer to reset as soon as the program is run, which means that the timer will reset once the second that the robot is turned on. Now this is not ideal, however, because suppose that there is a short time lapse between when you turn on your robot and when the round of the robotics competition actually begins, such as you're on the field turning on the robot, then you have to get back off the field, and the ref has to get in place and then say that the time has begun. So this time lapse will cut into your time that your robot is set to accept commands, which means that your robot will stop moving and will stop accepting commands before the competition round ends. And if this happens, then you can miss out on scoring plenty of points because your robot will stop accepting your commands before time has been called. So this is obviously a problem that we need to solve, and one solution to this problem is to use your remote control to signal when the robot will reset its timer and begin counting time. This method can be applied by adding an idle loop to your code that will only end when one of your remote control buttons is pressed. Now, an idle loop is a while loop with an empty body. For example, here there's a while loop that says for 2.5 minutes, do nothing. And the idle loop will cause a robot to accept no other commands until the condition of the loop becomes false. Now, keep in mind that the idle loop tells the robot not to accept any further commands at that point, which means if you set your robot's power levels to a certain level before activating the idle loop, it means the robot will be stuck at that power level for 2.5 minutes. So if you don't want your robot to move at all for 2.5 minutes, then you would put this at the beginning of the code. So now we'll view a quick video that will demonstrate how an idle loop can be used to make your robot wait until a certain button on the remote control is pressed before it accepts any other remote control commands. Note that this video was originally made to create a robot for the Minefield challenge, like some of the videos we watched last time, so there will be some information that is irrelevant to your robot's solution. However, the important lesson to take away from the video is how to get your robot to wait until you press a button before it begins to carry out tasks. Alright, so we'll view the video now.
The Minefield Removal Challenge is broken into two periods. The autonomous period, where the robot performs pre-programmed behaviors, and the user control period, where you have direct control over the robot's movements. You learned how to make the robot perform pre-programmed movements in the movement section, and how to enable joystick control in this section. So to have a competition-ready program, you should be able to put the code for the autonomous period at the top, with the user control code directly below it. Right? Well, almost. This is assuming that the code for your autonomous period takes exactly 30 seconds to run before your timer-controlled while loop starts. And that the competition judges don't need any time to do scoring before starting the user control period. In either case, the timer controlling your remote control while loop is already counting, leaving you with less time to actually compete. One way of solving this problem would be to have the robot wait for a specific signal from the remote control before clearing the timer and starting the timer-controlled while loop. In this lesson, you will use one of the remote control buttons to create a remote start for your robot. Consider the code shown here. While vexrt btn7d == 0. The program will repeat this empty body of code until the condition becomes false, causing the robot to do nothing until the loop ends. A loop with an empty body is called an idle loop. Start by opening the timed Minefield Retrieval program. Save the program under the new name, Minefield Retrieval Remote Start. At the top of the program, let's have the robot wait for the down button in group 7 to be pressed. Remember, a pressed button sends a value of 1, while a released button sends a value of 0. The loop, therefore, should repeat as long as the value is 0. Add a while loop, and set the condition to vexrt btn7d == 0. Download and run your program. And place your robot on the competition field. Try using the joysticks to move the robot. Wait a few seconds, then try them again. Press the down button in group 7 on the remote control. This will change the value from 0 to 1 and end the idle loop. Move the joysticks now and see if anything happens. The robot responds to driving commands and remains operational for the full 90 seconds. In this lesson, you used a while loop with an empty body, an idle loop, So make your robot wait for a button press before enabling user control. This will allow you to remote start your robot and avoid wasted time.
Alright, the video is over, so we'll continue. Now, now I'd like to talk a little bit about the details for the game pieces that will be used in the Elementary School Robotics Challenge. So, for the desalination technology that will be used in Objective 1 of the challenge, the game piece will be played by this container made of soft plastic that you see here. We have 2 containers of this material that have dimensions of height 6 and 5/16 of an inch and diameter of 4 inches. Now for Objective 2, if you recall, you will have to be placing the water inside of the geometric container that you print, and the game pieces that will be serving as the water are these 2-inch styrofoam balls. They are 2 inches in diameter, so these are the game pieces that you'll be placing inside the container and transporting from one side of the field to the other. Alright, and thank you for attending. That's all I have today. So if you have any questions, you can chat with me live on System Break right now after the video. And you can also contact me as needed at my email here, techadmin@system.org. And other than that, I will see you again for Workshop 5 on March 29th. Alright, thank you again. Have a good day.